Welcome back, Patriots. We're going to go ahead and get started on Lesson 6-3. Good news. We've got Lesson 6-3 and then Lesson 6-4, and that is the last lesson for 2020. After that, it's just going to be reviews and tests and all that sort of stuff. So let's jump in here. This is not going to take us too long. We've already done solving inequalities, but today we're going to do this thing called compound inequalities. Now, compound inequalities are when you have two types of inequalities strung together at the same time. Now, there's an and an or situation. You've seen this type of inequality written when we talk about domain and range. That's a compound inequality because what it really means is -3 is less than x and x is less than 2, all at the same time. And so because of that, we end up having only the region that's in between those two. Now, what you're going to see is that when we actually start solving them, we're actually going to be splitting it up into the two separate inequalities. Now, we've also got an or situation, and that's where we've got a gap in the middle, and it starts pointing towards the outsides. So, we just have to make sure that we're careful with those. Typically in my opinion, the ands are easier to solve and the ors take a little bit more work. Not because they're more difficult, just because it's extra work to do. So here's how we solve these. We just split the and ones up into their two separate inequalities and solve. So I'm going to split this into -9 is less than or equal to 4y minus 3. And also 4y minus 3 is less than or equal to 13. Now just solve those two independently, and we are good to go. So we're going to add 3 on both sides. Gives me -6 is less than or equal to 4y. Then we're going to divide by 4. Gives me y is less than or equal to -1.5. Over here on the right-hand side, again, we're going to add 3 to both sides. 4y is less than or equal to 16. Now we're going to divide by 4. And that gives me y is less than or equal to 4. Now, when I graph inequalities on a number line, I always prefer it to be written like this, where the inequality is on the left. So this guy over here on the right, I'm going to go ahead and flip around. Make sure that when you flip it, you flip the inequality sign with it. And the reason that I like that is because, let me go ahead and put my numbers on here. So it's equal to, so that's going to be a closed dot. That's equal to, so it's going to be a closed dot. Now, the reason I like that is because essentially with a less than or greater than sign, if the variable's on the left, you could always just draw a horizontal line out of it, and that less than or greater than essentially is the arrow, which is the direction it should be pointing. So here from -1.5, I need to go right. And from y is less than 4, I need to go left. And so I'm going right from 1.5, left from 4. That means it's the area in between them. Let me make that smaller. There we go. Okay, this or inequality, we're just going to solve it, or solve the two of them separately. So we're going to add 7. Gives me m is greater than 4. Now we're going to subtract 1, which gives me -2m is greater than 0. And now we're going to divide by -2. And now remember that 0 divided by anything is just 0. But remember one of our inequality rules, the only way that inequalities are different from equations is that when I divide by a negative sign, I'm going to flip the inequality over. So because I divided by a negative, that greater than becomes a less than. So I've already got my variable on the left on both of these, so I'm going to go ahead and just plot them. I've got a 0 and a 4. Now, from the 4, m is greater than, so I'm going to be going right. And from 0, m is less than 0, so I'm going to be going left. And I should probably put my dots on there. These are going to both be open circles because there is not an equal to sign. All right, 2 more of this type. Now, let me show you a nifty little trick you can do on these and inequalities. You don't necessarily have to split it out like we did here. You could just realize that it was the exact same solving steps on both of them. Here, I added 3 on both. Here, I divided by 4 on both. So I could solve these two inequalities simultaneously. Now, here's what I mean by that. I am going to subtract 8 in all 3 places. Negative 2 minus 8 is negative 10, is less than 4x, is less than 12 minus 8 is 4. Now I'm going to divide by 4 in all 3 places. Negative 10 divided by 4 is negative 2.5, is less than x, is less than 4 divided by 4 is 1. Now realize that before you do that, the only reason we were able to is because over here on the outsides there were constants. The only place you see a variable, the x, is on the inside. If there's variables on the outside where the green marks are, you cannot do that. You have to split it apart into 2 different ones. Okay, but that's just a nifty little shortcut if there's constants on the outside. Okay, for graphing this, I'm going to put my negative 2.5. I'm going to put my 1. Both of those do not have the equals, so they are open circles. And then x is going to be between them. Okay, for number 4, we've got no choice. We have to solve these separately. Here we're going to add 3. That gives me 2x is less than or equal to negative 6. Divide by 2 gives me x is less than or equal to negative 3. And now, on the right-hand equation, or inequality, we're going to subtract 5 on both sides. Gives me 6x is greater than 3. Then we divide by 6. X is greater than 1/2. So we're going to plot our negative 3. We're going to plot our 1/2. Now here the 3 has an equal to mark, so we're going to go ahead and shade that dot. The 1/2 does not, so we're going to leave it open. And then x is less than goes left, and greater than goes right. So, not much different than what we've done before, just doing them at the same time. Realize these ors are typically going to be going out, and the ands are typically going to be going in. Okay. Now, we're going to be solving inequalities that have absolute value signs in them. These are not too difficult, provided that you understand that whenever you get to the section of the inequality where you have to do both the positive and negative version, you have also got to give not just a negative output, but also a flipped inequality sign. And that's because of the whole negative idea. When we divide by negative, the inequality sign gets flipped. Same idea. We're also going to make sure that we isolate the absolute value first. That's what here number 1 is telling us to do. Get the absolute value signs by itself. And when you look at all of these, you'll notice that on number 1, the absolute value sign is already by itself. Same thing with number 2 and with number 4 over here. I just realized I skipped number 3. Oh well, we'll roll with it. However, over here on number 5, that absolute value sign is not by itself. So we're going to have to do some solving steps to isolate that first. Okay? But the only time that's going to happen is on number 5. So, number 1 and 2, the purpose of these is just to get you used to the mechanics of how we do this. Now, what we're going to do is we're going to set up the original one, and I suggest doing this on the right. The original one we're going to set up as x is greater than 6. Now we're going to flip it, and we've got the negative 6, the negative version, but flip that inequality sign to be greater than negative 6. The reason that I suggest doing it this way is because in most cases, you're going to end up with your smaller number here on the left, so your negative 6, and your greater number on the right, which makes them in the right positions relatively left and right for how you're going to put them on the graph. Now, I always like to put the 0 on these, just because remember, absolute value is always measured as distance from 0. So I'm also going to have my negative 6 and my positive 6. And these get open circles because it is not equal to. And x is less than 6. I'm sorry, greater than negative 6 means I'm going right. Less than 6 means I'm going left. So it's all of this here in the middle. Now, the last thing we're going to do on this after we graph it is we're going to rewrite this as either an and or an or. Now for the ands, we just write it as a compound inequality. We just write it as negative 6 is less than x is less than 6. So x is between negative 6 and 6. If it was to have gone outwards like this, then we would have to rewrite it as an or inequality with actually the word or in it. Okay, so on number 2, we've got absolute value of x is greater than 4. Now remember, write the positive version on the right. So x is greater than 4. Write the negative version on the left. X is less than negative 4, making sure we flip that inequality sign. So here's my 0. Here's my negative 4. Here's my positive 4. Those both get open circles. And if x is less than negative 4, that means we are going left. And if x is greater than 4, that means we're going right. So since they're kicking outwards, that's an or inequality. And so all I'm going to do is I'm going to write the word or in the middle. And there's my answer. Okay, now we're going to do one that's got a little bit more detail in it. So the absolute value sign has been isolated as by itself. So I'm going to again put the positive version on the right. 3x plus 5 is greater than or equal to 14. And the negative version goes on the left. 3x plus 5, flip the sign, is less than or equal to, and flip the sign, the negative sign to be negative 14. Okay, now we solve. Negative 5 on both gives me 3x is less than or equal to negative 19. Divide by 3, x is less than or equal to, well, 19 thirds is not a nice number. That's negative 6 1/3, or 6.33 repeating. On the graph over here, I'm going to leave it as negative 19 thirds. Now, this one says that it is less than or equal to, so I've got my closed dot, and if it's less than, it's going to go left. Okay, now let's do the right-hand side. Subtract 5 on both sides. Gives me 3x is greater than or equal to 14 minus 5 is 9. Divide both sides by 3. Gives me x is greater than or equal to 3. So I jump over here to my 3. Equal to gets a closed dot, and greater than goes to the right, which means this is an OR inequality. So the way I'm going to write this is x is less than or equal to negative 19 thirds, or x is greater than or equal to 3. Now also let's remember what these graphs actually tell us. If I was to put a dot anywhere on this graph inside of the arrows, then that would be part of the solution set for this inequality. So for example, if I was to put a dot over here at 4, then yes, 4 is a solution. If I was to come over here to negative 10, then that is also a solution. However, if I was to put a dot here at 1, 1 is not a solution. Okay, so the graph's going to help us figure out what numbers actually make these things true. Okay, number 4 is going to involve a little bit more work. Remember, our goal is to get the 4p plus 2 by itself before we do anything else. So, if I was to pretend like that was just its own variable, like for example, if this was just 6x minus 8 is less than 34, what would I do first to get the x by itself? Well, I would add that 8. After I've added 8, then what would I do? I divide by 6. So I'm going to do the exact same steps here to get the absolute value by itself. I'm going to subtract 8 on both sides first. Leaves me with 6. Absolute value of 4p plus 2 is less than 34 minus 8 is 26. Whoa, I should have added 8. Thank you for catching that. So then 34 plus 8 is 42. Now we're going to divide everything by 6. Gives me 4p plus 2 is less than 42 divided by 6 is 7. Okay, now that we have this isolated, ooh, that does not look good with the green on top of, or blue on top of green. But now that I have that isolated, now I'm going to split it up into its two inequalities. So I've got 4p plus 2 is less than 7, and 4p plus 2 is greater than negative 7. Again, we flip the sign of both the inequality and of the constant over on the right, of the 7. Okay, so now we're going to subtract 2 on both sides, giving me 4p is greater than negative 9. Divide by 4, p is greater than negative 2.25. Over here, same steps, subtract 2. Gives me 4p is less than 5. Divide by 4 gives me p is less than 1.25. So I'm going to put in my negative 2.25, my positive 1.25. Now, those both get open circles because they are not equal to. And P is greater than negative 2.25 means I go right off of this arrow. Less than 1.25 means I go left off of this arrow. That means we're looking at an AND inequality, so we're going to rewrite it as P is greater than 2.25 and P is less than 1.25. So P is between those two values. So that's all I got for today. Good luck on the homework. Let me know if you need any help.